In this next project, we're going to continue working with classes, right? We want to put that into practice and kinesthetically get some experience working with classes and using them in our code. So the first class we're going to code is the checker class, and it encapsulates what a checker is and what a checker does. And the next class we're going to code is the player class, and it encapsulates what a player is and what a player does. Okay? So let's take a preview and see what this code does. So here's the main menu. I'm going to choose to play checkers, and it basically builds checker objects and populates a board of 64 squares with checker objects. Who do I wish to play? I want to play the computer. What's your name? Carly. Do you want red or black? I'm going to choose red. Carly chooses red, therefore computer is black. Press enter to continue. It draws out our checkerboard in ASCII. Here is my stats, and here's the computer stats down here. Carly, which checker do you wish to move? And I'm bound by the rules of checkers. So I'm red, and I couldn't go straight forward. It has to be a diagonal. And I can't go horizontal. And I'm not a king, so I can't move diagonal backwards. I can't go here, here, here. The only position I could move this checker if I selected it would be here. If I selected this checker, I can move it either here or here. And if I selected this checker, I can move it here or here. You follow? So we had to code, basically we had to code what legal moves are versus what illegal moves are in this example. So I'm going to select the checker here at 3-1. So the syntax for that, 2 digits, each one is counted as either a row and a column. So 3-1. All right, so it puts parentheses around it. That's a selected checker now. And so what I want to do, I can't jump anybody. Nobody's there. Let's attempt to move it to a different location. I'm going to choose M. All right, so where do you wish to move it? I can't go straight forward, and I can't go horizontally, and I'm not a king, so I can't move backwards. So the only valid option I have with that checker selected is I have to move it diagonal. So it's at 3-1. I can move it to 4-2. Can I not? So I'll pass in 4-2. So it tells me current position is an odd number. That's an acceptable and legal move. Moving to, and then notice it moved my checker here, right? So my checker moved from here to here diagonally. Carly's move has been completed, and that's what the board looks like now with that checker. Okay. Now this particular project I've left unfinished. So I have coded the basic move of a player, but I haven't got to the point of actually coding the computer's moves yet. I'll leave that up to you. And this is a project that you can work on and implement your own creative ideas and things. But I'll go over the code that I have so far. And if you work on this project, if you choose this project, this will give you some good practice with classes and arrays. And lots of nesting decision structures. This project will give you practice, just like the blackjack game and the tic-tac-toe game. It'll give you practice with everything we've covered so far. Okay? So in our global namespace, we have a couple of constants and then some globals. And we need a player object. In this case, either 2 human players. My eventual idea was to have either 2 human players or a computer player. And we need a 2-dimensional array to represent a checkerboard, which is like 64 squares, right? Same for a chessboard. So we have these, and they exist now in our global namespace, so we can pass them around. All right, so our checker class, when we code it, we have these data members, right? It could be red, it could be black, it could be blank. Those are the 3 possible states of a square on the board. It could be blank, it could have a black checker, it could have a red checker. Okay? Constants, now our data members, is the color. Is it red or black? Or is it a blank one? And is it a king? If a checker can only move backwards if it's a king. So when we start coding that behavior, we'll need this data member. And when you're designing a project and you're coding a class, you want to kind of plan it out, sit back and think, well, Eventually, if I'm going to write functions that deal with backwards and forwards behavior, I'm going to need to have those data members in my class, right? Because a checker can only move backwards if it's a king. Otherwise, it can only move forwards. That's its only legal move. So that should be a data member. Color should be a data member. Is the checker selected? That should be it's just a Boolean, but what checker did the player select? Have to make sure they select one of their checkers. Have to make sure it's not blocked in, that it can make a valid move diagonally, and have to make sure they didn't try to select the opponent's checker. You never know what the player's going to do. They could do something crazy. Okay, what's going on here? We have overridden the constructor, and we've overloaded the constructor, right? So overriding and overloading, like we talked about before with the blackjack game. In this example, we have a constructor that takes no arguments and a constructor that takes, a single parameter here. This will just create a plain old generic checker. Its king is set to false and selected is set to false. Same thing here, but we can pass in a color. We can choose a red or a black checker, okay? Created A, and then black, red, or blank. It's just going to display that in our constructor and then output that to the console, that string, right? Get checker type. Well, we're going to pass in what's selected and the color, right? So if it's black, we're going to return black with parentheses. And if it's red, we're going to return red with parentheses. We can only do so much with ASCII. We haven't got to graphical interfaces yet. And I don't believe in that. I believe you want to become fluid and adept at programming the console before you dive into creating GUIs and event-based programming. Because event-based programming introduces a whole new strategy of programming and a whole new set of possible errors. Because with a GUI, your user, your player, they can jump around all over the place in your program. And so bulletproofing becomes a lot more important. And you have to start thinking of all the crazy, insane, and possibly stupid things the end user is going to do when you give them a graphical interface. And you have to sort of guard or protect your code against that. And you have to listen for events, and you have to handle events, and that's a whole separate ball of wax. So I think, when I learn a new language, I always learn it on the console first, and I want to learn it well in the console without ever loading a single Windows form or a graphical interface. And then when I feel like I've got a good foundation of all the bits and pieces on the back end, when I know how to code stuff for the back end, which is the real meat and potatoes, that's the behavior code, right? Interfaces, come on. Once you learn the bits and pieces of a graphical interface, there's not much to them. But where the real meat and potatoes is knowing how to code logic, behavior, nested structures and things. So I would focus on this first, and in this series of videos I am, and then later we'll go into designing graphic interfaces. I know they're more fun, and I know that, it's nice to have colors and things and graphics, vector graphics and play sounds. We'll have fun with it, but for now, this is the console, and so we're limited to wrapping some parentheses around an R or a B for a red or a black checker. Yay! But this lets us focus on the code instead of instead of the graphical interface. All right, so it'll display that if it's selected, and else if it is not selected, this else block, no parentheses, just spaces around the checker. Okay. And we have accessor methods, and we talked about this before in PowerShell. We don't have to do this. We could allow our player, our code, to access the data members directly. But as an example, remember what we talked about in the video on classes. As an example, I'm showing you how it will be done in C++ or Java. And you could argue it's also done this way behind the scenes in PowerShell. This is how commandlets work, right? Every commandlet has a get method and a set method. Maybe not every one, but most of them, okay? Next we have the player class, and we have some data members. Every player object has a name, a color, red or black, and a score assigned to them based on whether or not they were able to jump their opponent's checker and how many they've collected in the process. We have overridden the constructor. All right, so we wrote a function with the same name that does our own thing, that's overriding, but we have not overloaded. Remember the difference between overriding versus overloading. Overriding is when you write a function with the same name that does your own thing, so you're essentially overriding a default method. And overloading is when you create more than one function with the same name, but they take different parameters, different arguments. And that's how PowerShell tells them apart. And the purpose of that overloading is to be able to use one function to handle multiple lists of parameters. It's a form of coding things polymorphically, or polymorphic coding, polymorphism. Okay, being able to create a function or method that can kind of, just adapt and change and evolve as it needs to, and yet you're still calling the same function name and able to pass in all these different types of parameters and numbers of parameters and so forth. So that's the advantage of overloading versus the advantage of overriding to do your own thing. Remember we said that it's advantageous to always display output when you instantiate something from a class or build an object. It can help you debugging. So in this case, we're just displaying creating a player object to the console. Same thing with our checker class. Any class I write, I will usually override the default constructor and have it give me some output, and then in the final version, I would just comment it out. So it doesn't always do that. See what I'm saying? Okay. We'll set a player name to be anonymous and their score is 0, initial values. Now, do you remember what we were saying regarding accessor methods? Doing the same thing here. We could access these data members directly in PowerShell if we wanted to. But remember, most PowerShell commandlets, there is always a get and a set, right? And the data itself is hidden, private, or protected. But the accessor methods are public. So that's where you get dash and set dash. That's what you do with commandlets in PowerShell. So I'm just emulating that here. I don't have to. It was a bit of extra work. My code would be simpler and probably easier to follow if I just access these data members directly, but I was trying to make this an example. So it's up to you. If you implement this project, you could leave all these out, these accessor methods and all these accessor methods. You could leave those out, and you could just access this data directly if you want to with the dot operator. So I'm giving you ideas. All right, we have a main menu. This is where they choose to play the checker, play checkers if they want to, and if they do, we go to the play game method or function. Okay, so let's look at play game. Oh my goodness, where is play game? Somewhere in all this code. Here, all right, here's play game. So if they go to play game, then play game turns around and it calls or invokes begin game. Okay, and we'll go to begin game. What happens in begin game? We're going to create 2 new objects, 2 player objects, and assign them to our globals so they will persist in memory even when begin game ends. Then we're going to call the function create board. All right. And where's create? All right. So we'll jump to create board. All right. So create board is blank. Starts out to be false, right? It's not blank. And what happens? We need several nested repetition structures. We have to create the first 3 rows of red checkers with spaces in between. All right. So while rows is less than 3, okay, and then x is less than 8 for the number of squares. So let's look at our outer for loop first here. All right. So try to highlight this here. This block our outer for loop. Rows is 0 while rows is less than 3. So that's rows coming down, right? Or in this case, we'll think of the red checkers, or invert it and think of the black checkers if you want. But so for those rows populated with checkers, and then in those 3 rows, right? Internally, we're going to start with x here, and while it's less than 8, okay? So those are our columns. And 8 columns, 3 rows. What happens if is blank is false? If there's starts out to be false, right? Is blank is false. If is blank equals false, do what? Checkerboard rows x, okay? So the first row, we'll start out, rows is 0, so that's the first row, right? Subscript value index 0. And then x is 0. So first row, first column, we create a new object checker and red, right? So if it's blank is false, then it's that checker on the board will be red. But if is blank is true, then there'll be that space will be set to blank. The checker itself will set that space to blank. Okay? And then what is blank is set back to false. Okay? And if not is blank becomes true. Otherwise, is blank becomes false. Right? Remember that exclamation point is not. So this just toggles is blank on and off. Okay? That's our first 3 rows of red checkers. Create next 2 rows of blank spaces for the middle of the board. And that's why we're starting at 3. So here we indexed 0, 1, 2, right? And now we're going to do 3 and 4 while rows is less than 5. There's our blank spaces. And then finally, now we need to do our black checkers. Up here we set our red. Down here we set our black. Okay? All right. So back to the calling method. That was create board. That populated the board with red checkers, black checkers, and the blank spaces in the middle. We will pause for 3 seconds. Start sleep, strategic pause, beginning new game. Who do you wish to play? Computer or player? And in this case, if we choose computer, then the player's name is the player's name, and then player 2, their name will be computer. Okay? And we're going to choose, right, based on what the player chooses. If the player chooses red, the computer is black. If the player chooses black, the computer is red. Okay? We need to ask the player their name, and we get that via read host. And just in case they were playing another human, we would ask both here if they choose to play another player and so forth. All right, so press enter to continue. Well, where did that, this begin game, right? It came from play game. So we finished begin game. We've created the board. The player has given us their name. They've chosen their color. We have all those preliminary things taken care of. So program flow would go back to play game. So in the play game function, right, it called begin game, and that called create board. Took care of all that. Now we're going to basically, in this loop here, while global keep playing, this is sort of our main game loop, right? Our main game engine. We're going to repetitively call select checker through each iteration until this becomes false, until no longer keep playing. So that will be for player 1, and then we're also going to call select checker for player 2. And so program flow at this point really passes into select checker, and in the game loop, it will keep passing back and forth between player 1 and player 2, whether they're a computer or a human, and just calling select checker over and over. So program flow is now moving to select checker, and select checker itself will select all of the other functions necessary for our game. So let's go find select checker. And let me actually go up here. There. So what does select checker do? Well, it starts out and initializes choice with an asterisk, whatever the player decides, where they have to select the checker to move, right? Current position, in this case we're going to create a multi-dimensional or 2-dimensional array. And to hold a column and a row, okay? And then we sort of have some compound logic here, okay? So in our while true loop right here, here's our opening brace. And way down here is our closing brace. And I added a lot of comment tags and I had to use a lot of indentation here because now you can see, I'm going to zoom out here and I'll show you what I'm talking about. This is just trying to code the basic decision structure for a legal move. And there's a lot to consider. Even checkers, which is a lot simpler than chess, there's still a lot to consider about what a legal move is, whether or not the checker is a king, affects whether or not it can move backwards. It can't move straight forwards vertically. It can't move horizontally to the side. It has to move diagonally, but diagonally within, acceptable squares. And if the opponent's piece or another one of the player's pieces is there, it can't move there. But if it can jump, then a whole nother set of moves becomes available, right? If it can jump over its opponent's checker pieces, or if it's a king, it could jump backwards. And so I'm just trying to give you an idea here of the logic involved, right? So anyway, while current position is less than 1, or current position is greater than 8, or current position 1 is less than 1, or basically if the player types in some craziness, we've only got 64 squares in the checkerboard, right? Yeah. So there's 8 rows and there's 8 columns. And if they choose something outside that, let's say that they choose 9 for a row. Well, there is no row 9. Let's say they choose, 15 for a column. Well, there is no column 15. And there's that off by 1 issue because we don't count 1 through 8. We count 0 through 7, right? Okay, so that's all this test condition portion inside the while true loop is doing here. It's making sure it's a valid move. As long as, if they keep selecting weird stuff, if it's less than 1, or if it's greater than 8, or less than 1, or greater than 8, in this case, then what? If we're going to keep them in this loop, we're going to keep displaying the board, and when we display the board, we're going to make them select a valid move, okay? So, what does display board do again? Remember? Display board just goes through, and we've got a for loop here, and it's going to draw out the rows and columns and display our board, okay? I'm trying to be fast with this because I don't have a lot of time to, but I'm trying to. And then in addition to that, we want to display the player stats, and you saw that when we ran it. And then we're getting the player color and displaying score based on if it's computer or player. And this is just numbering. So we're going to number our columns to make it easier for the player to numerically select, the checker they want to select and the square they want to move to in the game. Okay. So back to select checker. After it displays the board, we ask the player, well, where do you want to move? Or which checker do you want to move? Okay. So I have to convert it to a number because I have to do some integer comparisons, some numerical comparisons. So remember parse, and we're casting it to an integer here, right here, and right here. And then, okay, so keep playing is set to false. I'm going to go through, and same thing, I need to make sure it's valid, right? As long as it's less than 1 and greater than 8 for index item 0 and 1, if either one of those is outside the range in our array, hey, that was an invalid choice. So that if. Else, okay, so then it is a valid move. And then in this else block, all this code here. All right, so I've highlighted it. I wonder if I can zoom out and show all the, you won't be able to read it, but I'll try to zoom out. Let's see how good yeah. So you can see all that code there is what happens if that's inside that else block. Basically here, we need to go through and see what a valid move is. And we have to invert the logic for black. Whatever we do for red, we have to kind of invert that same logic for black, right? And that's all we're doing. We're stepping through here. You'll have to kind of carefully comb through the code or read through the code, and I'll paste the source, but in this case, we're using that array and we're adding 1 to determine which square we can move into. And then we're telling the player, hey, if they selected this piece, they would be trapped. That's not a valid move. They can't. We're going to make it so that they have to actually select a piece that they can actually move, okay? So that's where we're looking at current position. And we're just inverting that logic down here. And then if it's valid, okay, now that we have selected a checker, we need to call move checker and potentially jump checker, okay? So move checker, go down, we'll find move checker. All right, so we're gonna take as an array the current position with its row and column, and as an integer the color and the player's name, okay? And now, here we need to step through, check to see if the move is outside the numerical range, again using the index subscript values that represent the squares on our checkerboard. And check to see if the move is to, it's to spot with the checker already there. Check to see if the move is illegal sideways. So we have to make sure that there's not a checker already there. We have to make sure that they're not trying to move sideways. Check to see if the color is red. They can't move their opponent's piece, they have to move their own piece. So if they're red, it has to be red. Don't allow to move more than one forward if not a jump, right? So not only does it have to be diagonal, they can't move 2 squares forward, they can only move 1 square forward. Move must be diagonal on the board to be legal, and we're using the modulus operator to go back and forth between whether it's an even number or an odd number to tell. And if destination position is even, it's illegal, right? And again, just to kind of show you, I'm going to zoom out and look at the decision code. Look at the nesting here. All right, just to get the board position. And you can see all this code. You can see all the nesting here that's involved inside that method or inside that function. And I'm just too exhausted at this point to go through all this code. I will put the source code up here, and you can. But this is something that it'll give you great practice with arrays and great practice with classes and things, but you'll need to take hours and go through the code and then begin to make it your own. Begin to modify it and begin to change it and begin to add your own logic in. This is very much an unfinished project, but I chose to include it because I think it's great practice. But you need to go over the code with a fine-tooth comb. And I mean, I could literally spend 4 hours talking about the code in this little project. But, I don't see the point when you could read the code at your own pace. I think that would be more effective. Or copy and paste it into ICE and then kind of step through the code, okay? So anyway, just showing you that's how we select a checker, that's how we move a checker, that's how we decide what a valid move is. And I'm going to go all the way down here. And then the only other method that we really need to make use of is this jump checker. All right, so we have code for selecting a checker that's valid or not, code for moving a checker without jumping that's valid or not, and now we have to have code for jumping. So did they input numbers outside the valid range? Again, we have to test for all these logic conditions. Are they trying to jump where another checker is already at? Are they trying to jump sideways? Is it a red checker if they're red or a black checker if they're black? Are they trying to move backwards? They can't do that unless they're a king. Are they trying to move forward, more than one row forward to jump? Is it an even number? If we want to tell if it's diagonal. Is it blank and 2 rows ahead? It has to be blank and 2 rows ahead. Are they moving to the right? And is it a legal jump over the opponent's checker? Right, because it's always diagonal when you're jumping someone. So these 10 areas of logic are the things we have to test for here. See what I'm saying? And again, look at the nesting. Look at the flow of logic here. See? That's all for jumping a checker. Okay. And finally, what if it's a double jump? There's even another contingency we have to code for. Well, what if it's a double jump? And we have to code that as well. Okay. And this is just some testing I was doing when I was setting up my 2D arrays to make sure that my moves would go right. But I will throw all this code. This project is very much unfinished. But here's what it does so far. So if we run it, play checkers, all right, so it builds the array and populates it with checker objects and blank spaces. That's our board. I want to play the computer. I give my name. I want to be red, enter, draws out the board. That's display board. I'm going to choose the checker right here. All right, so row 3, column 1. That's the one I want to select, 3, 1. Okay, it decides, okay, I can do that. So now it wraps it in parentheses, right? Haven't done anything with square yet. What I want to do, move to another location, attempt to jump. I can't jump. There's no, there's no opponent anywhere. My only choice is to move, and it has to be diagonal. It can't be, straightforward, and it can't be horizontally to the side. It has to be diagonal. So I'm at 3, 1. I want to move to 4, 2. Follow, row 4, column 2. So that's what I would input, 4 and 2. Oh, hang on. I have to hit M first. Not paying attention. All right, so 3, 1 is selected. I want to move to 4, 2. Like I said, you never know what the end user is going to do. So, all right, so I moved the checker from this square, right, to this square. Okay. And then I deselected the checker once it moved. Okay. All right. So that's what I've got so far. This project could use quite a bit of work. Maybe this is something we could all work on together. It'd be fun, but as we get time, this project will be thousands of lines of code when it's done, and it's going to take. It has quite a bit of logic in it already for coding what is a legal versus an illegal move. You saw that nesting. And it's currently, how many lines? All right, so about 1,725 lines of code. I'd say by the time we finished it, we could easily have 4,000 or 5,000 lines of code. Depends. But, how fancy we want to make it and how many bells and whistles we want to add into it. Things like that. But so just be a good project to practice classes and arrays and things. But plan to spend a large amount of time. Like I said, I could spend hours and hours talking about this, and I don't even know it would do any good. When really what you would need to do is step through the code, copy it, paste it into ICE, and you spend hours working through the logic, the nested decision structures to see. I tried to neatly format the code to make it clear and evident, at what level a decision is taking place. Just imagine if I was a sloppy coder, and if this was spaghetti code, there'd be absolutely no figuring it out. With 10, even 12 different layers of logic nested in one inside the other. So that is sometimes where indentation and writing neat code comes in handy. Where it's a really good thing. But again, just a checkers project.